Screen
This
is visible
conference will now be recorded.
So just to check, am I still audible?
Yes, Mandar.
Yes. So I'll go into the presentation mode now, and we will start. So first of all, thanks to dear Azure, I'm grateful for the opportunity to speak today. So before we begin, if I sound a bit nasal in between, pardon me, because I'm just recovering from a cold. So having said that, hello everyone, and good afternoon to all. Thanks for attending today's session. The title for today's session is how to build a serverless helmet detection system using custom vision, Azure Functions, Event Grid, and Logic apps. My name is Mandar Dharmadhikari, and I'm connected today from the beautiful city of Churches, Adelaide, in South Australia. So before we begin, a little bit about me, since this is my first time presenting here in the Dear Azure community. My name is Mandar Dharmadhikari. I am an integration developer and administrator. I basically work with Microsoft BizTalk server product and deal with its development and administration. And I also work with some of the cloud components like Logic Apps, Azure Functions, Event Grids, and other bits. Apart from that, I'm an integration and AI enthusiast. I like to explore Microsoft Azure's uh, offerings around them and like to play around and learn new things. I'm a Microsoft TechNet Wiki ninja, and I like to write articles on Microsoft TechNet Wiki and other forums. I am reviewer for few of the Azure-centered video courses offered by Packet Publication. And when I'm not learning new things or working, I'm a diehard fan of Metallica, Dragon Ball, and Game of Thrones. So below are my contact details. So if anybody wants to get in touch with me, ask me any questions, or just have a friendly chat about Azure, you can contact me on any of the channels below. Last is my GitHub handle. I'll share the contact details once again at the end of the presentation. So before we discuss today's agenda, I would like to say that there are various components that were used in this project. Yeah, given the time constraints that we have, I will highlight only the basic concept of these offerings. There are many fantastic presentations out there. Probably one place to look at is a YouTube channel called as Integration Down Under, which we have here in Australia, which basically deals with the integrations offering of Microsoft. So you can check out the channel. There are fantastic videos there. And if you want to learn about the integration concepts that I'm discussing today, that's a great place to visit. So that being said, we'll cover following topics today. So following other takeaways from this session. So you can understand the basics about Azure Custom Vision Service. Then we'll take a look at Azure Computer Vision Service and why it's used in the project. What basically are the logic apps? What are Azure functions? Then what are event grids and why use them? Then I'll go over the architecture of the system that is designed to detect helmets. Then we'll do a quick peek of the code, and I'll show you a demo how the system and different components fit together in a serverless way. And at last, I would like to discuss the use of application insights to monitor system, which include logic apps and Azure functions, and how it's beneficial for us. Once that is done, I'll cover some best practices that and the issues that I've faced in this while developing this project, and how we can avoid them. And I'll point you to some reading resources, and we'll take some questions. So recently, I have started experimenting with the custom vision service that comes as a part of the suite of cognitive services provided by Microsoft, and it's hosted on Azure. The cognitive services offer several specific AI or machine learning tasks provided as services via an API. that we can integrate into web, mobile, and even desktop application. And the greatest advantage is that it uses the lightweight JSON-based REST calls or HTTP. And in many cases, it also provides a high-level client library. So the custom vision service allows us to build, deploy, and optimize custom image classifiers, which in turn allows us to tag various images according to our need. And this also allows us to apply various labels to the images, and as I said, tag them. What it does is it opens up the for us the avenues of object detection and classification, and we can explore them and create our models according to our need. There are several out-of-the-box algorithms, or rather domains under which we can tag our models for our different scenarios in the Azure Custom Vision service. So I'll show you later on how that works. Another great advantage is that it supports in portal as well as SDK based developments of our model. The most beautiful thing that I find with Azure Custom Vision service is that we can export the model and run it on the devices or as containerized apps. So it allows us to deploy our model close to our data or where the data originates. For example, in case Azure IoT Edge, wherein we can deploy our model onto the processor like Raspberry Pi, and it works, recognizes the images there, and exports the data later on. A typical development cycle for Azure Custom Vision Service can be classified said to be first we first upload the images, then we tag the images in the areas that we want the model to detect later on. Once that is done, we train the model through the portal or either through the SDK, and we publish the model then, and then we test it, and we repeat the same process till it gives us results according to our expectations. Then let's see what Azure Computer Vision Service is. Before we move on to that point, that I would like to make is the payment for the services for Azure Custom Vision works as a pay-as-you-go model, where cost will depend upon the usage. And I would like to point out that the free tiers that are provided by Microsoft are sufficient for us to experiment and play around with the cognitive services that Microsoft offers, and it also can be possible to run small production workloads on it, though it's not recommended. So in short, custom vision allows us to manage our own model for detection or classification, while it still abstracts the machine learning part and the underlying training and algorithm that is used, which gives us the ability of faster developments and faster release of the products. So coming back to Azure Computer Vision Service, it's another cognitive service offered by Microsoft, and this caters again to image analysis. A major difference between computer vision and custom vision service is that computer vision is trained and managed by Microsoft using some predefined algorithms, while custom vision grants us ability and freedom to tag and train the model based upon our specific domain. So some of the salient features of computer vision are to analyze the images using predefined and trained models, and we can extract rich information from the image. We can perform optical character recognition and can also do handwritten and printed text extractions from the images. And day by day, the accuracy of the model is getting better and better. So it's really fun stuff. One out-of-the-box feature that comes with Azure Custom Vision Services is its ability to recognize famous personalities, people, places, landmark, etc. So we can use it in fun projects. For example, I have used it in a chatbot which is designed to help children to understand who the famous personalities are. So we can do fun projects with this feature. It allows us to generate thumbnails. So there are many more fun things which the computer vision service can do. I would urge you to explore the Microsoft documentation on this. Really fantastic stuff out there. So computer vision again supports lightweight JSON-based, REST-based API calls, or we can still use high-level SDKs for the development using .NET and Python. The service can process image in two ways. Either we pass it to the service as a byte stream, or another way is we pass the URL of the image. So if you want to play around with the Azure Computer Vision Service, just go to the landing page of Azure Custom Vision Service, start giving certain URLs to the testing console that we have there, and see the magic happen. And again, the payment for Azure Custom Vision Service works with pay-per-usage model. The free tier offerings again are very generous, which can easily be used for experimentation and exploring the features, and probably even uh, trying certain low-level production loads. But again, that's not recommended. Another feature that I missed to point out is that again it can be run as a containerized app closer to our data, which I think is again a good option to have. So moving on to the next slide, I'd like to cover some basic concepts about logic apps. Now this is my core area of interest. Uh, Logic apps uh, again are discussed in detail in several blogs, and the Microsoft documentation for this is again extensive. So anybody interested, I urge you to check it out at a later point of time. So at a high level, logic apps are a part of the Azure integration services that Microsoft provides. It resides at the heart of integration platform as a service story of Microsoft, and its another brother is Microsoft BizTalk Server. So Microsoft BizTalk Server works as an integrator on the premises, while Logic Apps work as an integrator in Azure. And with the help of on-premises data gateway and ability of BizTalk Server, we can connect uh, integrate integration in cloud to integration on premises, thus making it a hybrid integration story. Logic apps are completely serverless, as the Logic app runtime engine is completely abstracted from us developers, and it's maintained completely by Microsoft. This makes Logic app truly a platform as a service offering. Now, what it does is it allows us to automate workflows and orchestrate business processes. The integrations can range from simple data management to enterprise to business, and even application integrations. Logic apps work with designer first approach, where the development is done using easy to use designer, quite similar to uh, the BizTalk, if we have a BizTalk developers here in our midst today. Logic apps have around 300 out of the box connectors, and I'm not sure about this count because this count changes quite often, and newer and newer connectors are added every few days or every few months in the release cycle of Logic apps. So these connectors help us to develop lightweight integrations because we need only to configure few details, but probably in case of APIs, some headers, some keys, and then directly pass the body to the body, or even the IDs to the REST API, and it does the underlying work for us. So Logic app basically have very or no code component to it. So it becomes easy for even non-business people to learn Logic apps, and not much of a without much of a difficulty. So The question then arises, why use logic apps? Now, first, from a businessman's perspective, Microsoft or rather Azure Logic Apps provide serverless integrations. So the organization saves money on hosting the actual server farms and maintaining them and providing electricity for them, cooling them. So all these costs are avoided. Logic apps work, as I said, with connectors, and we have to write very less or no code. So what this allows us is to connect legacy systems to new cutting edge systems using logic apps on cloud and BizTalk server on premises, and set up the hybrid integration in very less time. So what this less time provides is basically the ability to reduced time to release a certain product or a certain API to the consumers in market. Then, since it's an integration platform as a service, now platform is an important word because as it's a platform, it's maintained by Microsoft. All the engine intricacies and maintenance is abstracted from us, so that causes a reduced operational cost in terms of not maintaining the server farms, not maintaining or not doing OS patchings, vulnerability managements, installing cumulative updates, stuff like that. So all of that is taken internally care of internally by Microsoft. So we don't really need to have a team of Wintel engineers to maintain it. So that's a plus point for business. Another great feature for Logic Apps is micro billing. So we only pay for what we use, and no, unlike the certain app service plans for web APIs, we don't need to provision certain plans beforehand to host our web APIs. Here in Logic Apps, you only pay for what actions are run in your workflow. Now, from a developer's perspective, Logic app, as I said, uses very less to no code. So it's easy to design it using Azure Portal and Visual Studio. There are few quirks while developing the Logic apps using Visual Studio, but those are not that difficult to overcome. Now, Azure Logic Apps support Azure Resource Management templates. So what it does is it makes the deployment easy and repetitive for us. So we can configure the template once and we can deploy the same logic app in multiple regions with just a PowerShell script. It's that easy. It also gives us ability to set up continuous integration and continuous deployment of logic apps using Azure DevOps pipelines. And we can even, I believe, use Jenkins, though I have not used it. And Logic apps have around 300 out-of-the-box connectors for API consumption. What this means is I'm not concerned with underlying plumbing code to connect my workflow to other web APIs. I just need to drag and drop or add the connector, configure it, and boom, it's there for me to consume. Another beautiful thing is if we are writing a custom web APIs that are hosted somewhere and we don't have a connector for that, just by authoring open API documentation for our web API, we can simply create custom connectors for logic apps. So again, it's a nice little feature to have. So then moving on to what are Azure Functions. Azure Functions provide the other side of story of running serverless workloads. So Azure Functions are serverless compute service, which are run on the platform completely abstracted from developers, thus making it again truly serverless in nature. So what Azure Functions are is that they are just small pieces of code, small methods, if you will, if you are considering it from a C# or any programming perspective, and these run on the Azure Functions runtime platform. They have a plethora of triggers and bindings for us to connect them to different offerings. Examples of triggers or binding would be that I have a HTTP trigger that my Azure functions get triggered using a HTTP trigger, or it gets triggered at a particular point of time. We can use the timer trigger. We can use event grid trigger to react to something that's being put on the event grid. And we can connect them to other end systems, like we can send mails using the send grid trigger. We can use the uh, Cosmos DB binding to connect to the Cosmos DB. We can use Azure Blob Storage binding to connect to the Blob Storage, and so on and so forth. There are a lot of bindings out there. Another feature of Azure Function is that they are multilingual. They support development in a lot of different languages. Some of them are C Sharp, JavaScript, PowerShell, F Sharp, just to name a few. So whatever suits you, you can always use it. Now, as I mentioned earlier, logic apps were no to less code approach of creating serverless workflows. Now, Azure Functions present the completely different side of the coin here. So they are developer oriented, developer free, because we have to write code to get the Azure function to perform a certain work. So what this allows us developers to do is that we can do local development and debug them on our local environment using the Azure function core tools. And so what this gives me the ability is to test my function, write unit test cases for them, write functional test cases for them, test them before I actually deploy it to Azure, which sadly is not possible with logic apps. So if we want to test the integration using logic apps, we have to deploy them to cloud. Another great function of Azure Functions is that it can be run as a containerized Docker app, and can be deployed again on Azure IoT Edge. And even we can deploy them on our local Windows or Linux machines. So if any of us who are Azure Function developers, till now, Azure Functions did not support .NET Core based dependency injection, but recently an announcement was made that Azure Functions will now support dependency injection, which basically means that there are no more static functions. And this was my reaction when I found it out, because we had to do a lot of plumbing code, basically use autofac as a dependency injection and dependency injector and service locator pattern to locate certain instances. So it's a really happy news for Azure Functions developers. So coming to the last offering that is used in this project, it's Azure Event Grid. So Azure Event Grid is a fully Microsoft managed routing service, which delivers event notification using lightweight HTTP call. The Azure Event Grid is baked in the Azure, and by default, many Azure activities that we perform may trigger some kind of event. A simplest example of this would be I'm creating a new resource group. It will trigger an event somewhere on the Azure Event Grid, and I can subscribe to that event, and I can react to it if I want in a particular way. Another event can be when a blob is created or deleted in a particular container or in a storage account. So our solution or our automation script can monitor and listen to this particular event. And if it occurs, it can set up some notification like sending out mails or copying the blobs and other things. The lightweight notification allows us to develop event-driven solution, which work with publish-subscribe model. Again, if we have some Bestock developers here, they might relate to this publish-subscribe thing. Else, it's a standard. It follows a standard publish-subscribe type of architecture modeling that we have. Then a great feature of Azure, what it basically does is it promotes loosely coupled architecture style for me. So my components are loosely coupled, and I can take out one component at a time, do its repairing, fix its bugs, deploy it once again, and ideally this other parts of system can still function. So a great feature of Azure Event Grid is that not only it supports the various events that are emitted by Azure itself, it allows us to emit custom events of our own. Azure supports two type of schemas. One is event grid schema, which is internally defined and used by Azure to emit its event in certain specified form. So we can use the event grid schema to author our custom events, or we can use uh, schema from cloud events, which is again open source schema format, and we can put out our uh, events onto the Azure Event Grid. What we need to then do is we need to apply filters to our subscribers so that the subscribers can subscribe to certain events only and not all of the events. So another great thing about Azure Event Grid is that it has very high throughput and resiliency. It is very cheap, and the billing is done using pay per event billing model. So every event that you subscribe to or every event that you react to causes you, or rather incurs some cost. But as I said, it is fairly cheap, and you can still experiment around with Azure Event Grid. So if we take a look at the image that is there on the right hand side, we can see that following event sources publish various events. For example, blob storage publishes events like when a certain blob is created or a blob is deleted from the storage account, that puts or rather publishes an event onto the event grid. For example, resource groups can do publish events like a resource group is created or certain changes are made in the resource group that can trigger events onto the event grid. As your subscriptions can also trigger events, event hubs, IoT hubs, service bus, Azure Maps, and even we can push custom events of us. So I'll show you in the demo how we can use the custom events to publish them onto the event grid and then subscribe to them with either Azure Functions or using Logic Apps or Event Hub or storage queues. So what I've used in my code is I have subscribed to the events using Azure Functions and Logic Apps. So I'll show you that in just a few minutes. So that completes the different offerings and their introduction. Now let's move on to the system architecture. So now since we are using Azure Custom Vision, which basically deals with images, what this app cannot do is it cannot analyze images from a video. Right now, we have to use certain other features to analyze frames from a video. So what it does is it reacts to the images that were captured using cameras, and the images are captured of the motorcycle drivers, whether they are wearing helmet or not. And what it expects is that the camera captures the face of the driver so that it can determine whether the driver, whether they have worn a helmet or not. Plus it expects that it can capture the nameplate of the motorcycle so that it can trigger the necessary infraction notifications to the uh, the culprit driver. So the entire architecture works is the camera uploads the images to a Azure Blob container. What this does is it triggers the event called as blob created, and it is published onto the Azure Event Grid. Then I have one Azure function which is listening to this particular blob created event from a particular container inside Azure storage account. So let's say my storage container is called input. So whenever an image is uploaded to input, I understand that this image is uploaded by the camera that is taking the actual pictures of the drivers. And once that is done, my Azure function gets triggered. It gets the URL of the blob from the schema, sends it to the custom vision project that I have developed. The custom vision then analyzes the image from the blob generates it's basically is object detection model. Now it detects whether the user has worn a helmet or not. If they have not worn a helmet, it will return me a tag as no helmet. If they have worn a helmet, it will return me a tag as helmet. So based upon that, whether the user wears a helmet or not, or another option, another scenario is that the object detection model is not successfully able to determine uh, the level of certainty with which whether the user has worn a helmet or not. So that probably lies somewhere around 40 or 50%. In that case, what we are supposed to do is we are supposed to initiate a manual intervention process. So let's say that my custom vision successfully determines that the user has not worn a helmet. So what it does is it triggers a custom event onto an event grid, which says that the user with this particular blob URL, or rather the user captured in this URL, has not worn a helmet. What it does is it sends it to another Azure function, which then sends the blob URL to computer vision service. And what it does is it extracts the number plate from the image. If it has successfully extracted the number plate from the image, what it does is it again triggers another Azure function, which basically goes to the database to query the details of the driver based upon the extracted number. And once they find the details, they send out a mail to the driver saying that you were captured driving a motorcycle without a vehicle, sorry, without a helmet. So I'll show you the demo in few minutes. Now, since this system is completely automated, there are chances that some unknown exceptions might occur, or even the object detection model is not able to extract or decide whether the user has won an image or not, or even the computer vision service is not able to extract out images, or if we get certain exceptions in our pieces of code. What this system does is, as a compensation, it triggers a manual or rather a custom event which says that the system is not able to cope up or not able to analyze this particular image, and this again is put out on a uh, event grid topic. And what it does is it triggers a logic app which is listening to sorry about that. It triggers a logic app which is listening to this event which says that the system is not able to successfully process this image. And what it does is it copies the blob that was uploaded to a particular. Sorry, was there a question there? Did I miss anything? Okay. So what it does is it moves the images from one container to another container, and this probably can be used to trigger a ticket in a ticketing system so that certain person can come and analyze the image and decide whether the driver was wearing a helmet or not. So it might sound a bit complicated at this point, but I'll show you how this system works. And the biggest advantage of this system is that it's completely serverless. No piece of it is running other than anywhere in the Azure. So it's expecting only images from the IoT device. That's it. And entire magic happens in Azure. And it's completely loosely coupled, no hard coupling in between. So even if I take out one part of the system, I can easily replace it with another during maintenance. So let's go to Azure Portal for this. But before we go to Azure Portal, I'll show you how the development for Azure Functions is done. Funny. So what we do with Azure Functions is that we have a class called a startup class, wherein we can inject all the dependencies that we want to. For example, in my Azure Functions, I have used computer vision client, custom vision prediction client, which basically deals with computer vision or which come with computer vision and custom vision SDKs. And then I have used cloud table client to connect to the table which contains the driver details. Other helpers are again implemented using interfaces, and what this startup class allows us to do as any ASP.NET Core startup class is to it allows us to inject all these uh, instances as dependencies, and then each of my function can define a constructor to which we can pass the dependencies, or we can inject the dependencies using constructor injection. So that's something that has been introduced recently. So anyone who is working with Azure Functions should try it out. So that being said, let's move on to Azure Portal. Let me quickly open up Custom Vision AI. So before we take a look at the different components, I'll walk you through the custom vision. Now, bear in mind that I cannot show you the actual images of the drivers and their numbers. So what I've done is I have trained a dummy model using free images from Google, but it still serves the same purpose. Let's just wait for it. So this is your typical custom vision portal wherein you can do the development. Let's wait for a second till it loads the projects that I have. So I have this project called as Helmet Detection App, and it is published to my resource group Helmet Detection Prod. So we'll take a look at that particular resource group in our Azure portal. But on a high level, this is how the images are tagged. So these are all the free images that I got from Google, and what I've done is I have tagged all of the images using certain tags. So for example, uh, so this image is tagged as a helmet because this person is wearing a old style helmet, for example. So what we need to do is we need to get certain images and tag whether the user is wearing helmet or no helmet. For example, in this image, I have tagged this particular area as no helmet. And what we need to do is we need to upload a lot of images for this so that the model becomes intelligent enough to understand whether it's a helmet or not. For example, in this image, again, there are two helmets. So what we need to do is we need to upload at least 50 images per tag and attach, or rather highlight the area in the image which corresponds to a particular tag, like this. That this tells the model that this area that it has detected and is a helmet, and during training then it marks this area as a helmet. So uh, and for example, in case of not wearing a helmet, marking it this particular face as no helmet tells, or rather helps the model train that the person has not worn a helmet. So the important feature or important point that we have to understand here is that we need to upload a lot of images so that the model becomes more and more intelligent. And as I mentioned in the slide, the typical development cycle is you upload the images, now you tag them, then you train the model, test its accuracy, whether it's at acceptable level, all good. If not, probably upload more images, tag them, again train the model, again test it. So it's a repetitive process till you get a uh, output of uh, desired output, basically. So if we take a look at the performance tab, it tells me that at a 50% probability threshold, what my model can do is the precision of my model is 93.3%. So what precision says is that this is the number which will tell you if a tag is predicted by your model and how likely it is to be right. Now, since I have uploaded around 50 images, so even only in the 50 images it has reached a 93.33% precision. So more the number of images, the higher precision your model have. Then recall defines the number of time, or rather a tag which was predicted correctly, and what percentage did your model correctly find. So these are some parameters that we can take a look at. Probably we can see the performance per tag. So for example, my no helmet tag had 100% precision recall was of 71.4%, and the image count was 28%, 28, whilst helmet was detected with 90% precision. So I'm particularly happy for this demo project, but as I said, we can improve it by uploading multiple images. And when you want to train a particular model, what you just need to do is click on train. There are two types of training. Fast training trains the model quickly, while advanced training takes some time and to train the model. So what this nifty little pointer says is use advanced training for improved performances, especially on challenging and fine-grained data sets. So with advanced training, you can specify a compute time budget for training, and custom vision will experimentally identify the best training. So it's a more advanced kind of training which you can use if you're using, or rather developing your model to be deployed to production. So fast training works for testing purposes, and that's it. So let's try to do a quick test for image. So what I'm going to do is I'm going to browse local image. So let's try with this image. So it should, or rather the model should detect that it has not detected any helmet in this scenario. This is the image which we will use to test our uh, system. So it says that it has detected this area as no helmet, and the probability is 85.7%, which can be increased, as I said, by uploading many images and training the model. So this is the project that I have developed for uh, identifying helmets, and Microsoft Computer Vision will be used to extract out number plates. So let's move on to the resource group. As I showed you, the app is deployed in this, or rather tied to this particular resource group. And this resource group only contains resources pertinent to this particular project. So what we have here is we have a registration for computer vision. So I'm listening, or rather subscribe to a computer vision service or API which is available in the Australia East region. Similarly, I have deployed my custom vision model to Australia East. And this registration custom vision API underscore prediction is used actually to make the predictions by passing the tags, or by passing the images using the SDK. Then we have a helmet detection function app, which contains various functions, which we'll go through in a moment. We have a custom event grid topic called as helmet detection result topic, wherein we push the manual the notifications for either that whether driver is wearing a helmet, not wearing a helmet, or whether a manual intervention is required in the system due to a catastrophic failure. There are two logic apps which are used to, or rather used as state management between calling of different functions. So one logic app called manage manual process workflow, basically what it does is when a manual intervention event is published onto event grid, this logic app copies the blob from the container where the blob was uploaded by the uh, IoT device, and it moves it to another container from which someone from the support team can take a look at it. Managed notifications workflow is used as state management and chaining engine, and it passes messages from one Azure functions to another. And SendGrid is used to send out notifications to the culprit drivers. This is the storage account where the supposed IoT devices to upload the data. So there is no IoT device here. I'm just going to upload the data directly to the blob storage. So I have two containers here. One is input and one is manual. So we'll upload our images to the input. This input simulates the container to which the IoT device will upload the data. Manual simulates the container through which the support people will actually manually send emails out to people who have not worn a helmet. At the same time, I have a table, NoSQL table here. Now we remember we can use Cosmos DB for Cosmos DB's table API. Now, since I did not want to spend money on it, I used the uh, cheapest one that was available, which was the table API. So if you want to take a look at the table API, I'm now in my storage explorer. So the tables that I have under this storage account is this. So this table has three details at this moment. So row key denotes your number, or rather the registration number of your vehicle, the name, and the email address. So it's a fairly basic table. What the function is supposed to do is it queries this table using the row key, gets the details like name and email address, and sends out the email. Fairly straightforward stuff. So let's move on to the Azure Functions. So I have developed these Azure Functions using Visual Studio and set up a continuous deployment using GitHub master branch. So whenever I push any changes to a particular repository of my master branch, it deploys the changes to the Azure Function app using a kudu build. So let's wait for the function app to load. So my function app, sorry about that. My function app has following functions. It's taking some time. Sorry about that. Let me try. Nice. So we have different functions here. So the first function is detect helmet. So this function is listening to the event which is called as when a blob is created. And this detect helmet function, what it does is it gets the URL from the of the image that was uploaded to the blob. And what it does is it then sends out the blob URL to the custom vision project. The custom vision then determines whether the user has a helmet or not. So in case if there are no helmets, what it does is it publishes the event which is called as no helmet detected event, a logic app which I have shown earlier, which is called as notify workflow logic app. What it does is it calls the extract number plate function first. This extract number plate function passes on the blob URL to the computer vision service, tries to extract the number plate. If it successfully extracts the number plate, it then invokes another function called as get driver details, which goes to the table that I've just shown you here. So the previous step should give this function registration number. And what it does is its only job is to get the name and email address from the table data. Once that is done, then there is another function which is invoked, that is notify driver and record infraction. So notify driver and record infraction function, what it does is it gets the number plate, gets the email ID, and sends out a mail using a certain template to a driver, which I will show you in a few moments. Then there are two helper functions. One is log to application insights, which helps logic apps to send and log events to application insights portal. Logic apps by default cannot log the events to application insights, but they log to log analytics. So in order to have the logging for the entire application on one platform, that is application insights, I send out certain events from logic app by invoking this function, and this basically logs it to application insights. Publish event to custom topic is used to publish custom events to the event grid topic. So what I want to convey here is that we write separate Azure functions to do separate tasks. So it pretty much is again based on the S of the solid principle, separation of responsibilities. So a good practice is, or rather a best practice is, that each function should only deal with a certain responsibility. So that being said, let's take a look at the storage account once again. If we check the events tab for the storage account, we'll see that we have an event subscription which is of a type webhook. So our Azure function is listening to this the events from this storage account using a webhook endpoint, and this tells you what subscription it is. So it is detect helmet parent function subscription, which I have created in the Azure function. Now, what it is doing is that it is listening for an event which is called Microsoft.storage.blob created. So this event is by default triggered in the Azure environment when you actually upload a blob. So in a reverse way, event of type Microsoft.storage.blob deleted is by default emitted when you delete a blob from a storage account. Now, advantage that I have here is that I only want to receive notifications or events, or subscribe to the events which deal with when a blob is uploaded to my input container, because that's where I'm going to get the images. So what it does is this: I have applied a prefix here which says that I want to listen for, or rather my Azure function will listen via webhook for Microsoft.storage.blob created event only when the event that is emitted out has a subject line which matches this. So this tells me that whenever a blob is uploaded to the input container, then only my Azure function subscribes to it. So that's how we can do the publishing and subscription, or rather, sorry, the subscription for the events that are emitted by default by Azure. Now let's check out the logic apps, or rather this custom event grid, before we move on to logic app. Now this event grid topic is used to publish events, two types of events: whether the user is wearing a helmet or no helmet, and another is whether a system has requires a manual intervention. So both of these again are of type webhooks, and there are two different logic app instances sorry, not the instances, but two logic app processes listening to it. And notice here the event type is completely blank. That is because this is a custom event and it's not recognized by Azure, but it still supports it. Now, if we take a look at the filter, one of the logic app is reacting to an event which says that a no helmet was detected, and that then it triggers other functions like extracting the number plate, notifying the driver, and stuff like that. And another logic app is basically listening to the event which says that a system has entered a catastrophic failure and we want a manual intervention. So this, what it does is it triggers the instance of a logic app which is listening to that particular event. So let's take a look at the manual work process logic app. So let's give it a second. Now I'm moving to my logic app designer. So what it is doing is it's listening via webhook for event which occurs on the event grid topic that I just showed you, and it's listening only for a particular event which has this manual tag in its subject line. So when it receives, what it does is it copies the blob from the event body, blob URL, and copies the blob onto another container, and then it deletes the blob from the input container, sends out, if it is successful in doing copying the blob and deleting it, it sends out a success notification to the logic, to the application insights using Azure Functions, saying that this name was copied for this correlation ID and the status was successful. If it fails, it logs a failure status. So this step is only executed if this step fails. That's it. It's a simple flow which copies blob from one container to another. Now, another logic app that we have is which actually manages the flow of messages between different functions. Now, there is another offering by Azure which is called as durable Azure Functions, which basically acts as state managers for chaining different functions together in different scenarios. So it's a choice between using Azure Logic Apps and Azure durable Azure Functions to get our job done. So I have chosen uh, Azure Logic Apps in this scenario. So what this Logic app is doing is it's listening for an event which says no helmet, and basically what it does is it calls extract number plate for function which internally calls the Azure Computer Vision service. Now if this function returns, this is a HTTP function, so now if the status code of the function is 200, then it means that I have successfully processed or rather extracted the image. Now, if it is true, what it does is it tries to get the driver detail from the table that is there using the extracted number plate. Once it has received the driver details, it notifies the driver using SendGrid. And if it fails to do either of these two things, what it does is it publishes the event that it has ran into a catastrophic failure, and we want someone to manually take a look at it. And as a end, now if my function is not able to extract out number plate, what it does is again it triggers a event saying that yes, I have ran into a failure. I want someone to take a look at it, and basically at the end logs the event to application insight. So that's how the entire system looks. Now I understand that it might be a bit disparate since it's not connected to anything, and everything is actually coupled to each other through events, which basically is loosely coupling. So now what I'm going to do is I'm going to show you the system, how it looks. So let me just delete this mail. Let's go to Visual Studio. What I want to do is create a new grid. Now I have two sample test data. One is a photo of Shah Rukh Khan from Jab Tak Hai Jaan, I guess. This is a failure case where the computer vision service cannot extract this number plate because due to some reason. And another is a photo of another actor called Steve McQueen. So here this rather image denotes a successful scenario where we can see the uh, system in action and sending out the mails. So what I'm going to do is I'm going to create a new GUID, copy it, bear with me for a moment. I'm going to rename this. And that's it. Now what I'm going to do is I'm going to upload it to the input container, which simulates my container where the IoT device will actually upload the data. So let's upload it here. Now it's uploading. Now I should get a mail here, which is from the DMV department. So let me delete the old mail also. Let's wait for a second or two. And if the demo gods are good, we should get a mail here. Yeah, so I got a mail here. So this is a template that I have, which says "Dear Jon Snow." Now the name is from the Game of Thrones, of course. So it says, "Dear Jon Snow, our monitoring systems have captured an image of you driving your two-wheeler with registration plates 1337 without a helmet, and infraction you have been fined $100." So, and it again attaches the snapshots so that we don't have any quarrel with someone who has been caught driving their vehicle without the helmet. So what it does is it allows us, or rather them, to challenge the system, and they can always use this randomly generated request ID to contact the government. So this, the details like the Jon Snow name and the registration plate and the email ID were obtained from this table data. So if you see this registration number, which is WH.1337, is fed here and has a name Jon Snow and my email ID against it. So that's how the system works. So what I did was just upload the image in the container here. Then the Azure function picked it up using the event grid, subscribing to the event grid, sent it to the custom vision project. It detected that the driver was not wearing a helmet. It triggered the law, published the event that the driver is not wearing a helmet. It triggered a logic app, which then sent the message to computer vision to extract the text, rather number. As it successfully extracted the text, it then sent it to the function which extracted the details from table, then sent a mail to me. So that's how the entire headless system works. So that's a happy or a vanilla scenario where uh, everything works as planned. Now this image of SRK, which where the number is still pretty clear, but the Azure computer vision still fails to extract a number from it. So it will show you how the system reacts when there is a failure in one of the functions. So what I'm going to do is again generate a new GUID. Um, let's try uploading this. Now what this should do is that since it fails, I know it will fail. Uh, this should move the blob from input to manual. So we have just uploaded this C08, C0C1. Now it should disappear from here in a few seconds. Yeah, it's disappeared, and it then appears in a manual folder. And we can check the timestamp here, which says that it was uploaded at 5:35 today. So what this means is that the system encountered a failure at one point, and uh, it then initiated a manual intervention. Now, since the system is entirely headless and completely loosely coupled, the question arises: how do we debug where it went wrong? Right. So that's where logging and application insights come into play. So let me just quickly move on to my presentation for a minute. So the question that I asked, how do we actually monitor the entire system in case of catastrophic failures like this? So the answer is application insights. And why application insights is because it allows us to monitor important metrics related to the application. And those important metrics can be something like the health of the application, the average processing times for request, response times. Then furthermore, application insight allows us to visualize disparate systems and interconnectivity them in between them using application map. It also supports real-time telemetry, and if we and it what it also allows us to do is run our query against the application insight database using a query language called as Custo. So what I'm going to show to you now is how this entire logging thing works. So let's just quickly move on to the Azure portal again. Now I'll show you how and why logging is important. So what I've done here is I have set up structured logging for my application. So I have defined certain event IDs, for example. Uh, so this is my logging template wherein I note down the event description. I note down what was the processing workflow which was processing certain request, what was the correlation ID, what was the name of the blob, what is the status of that particular step, and any log message that I want to log against it. Different event IDs that I have here is that pertaining to each function, I have defined different event IDs. For example, the helmet detection function, their event ID starts with 1000. Number plate extraction functions event ID starts with number 2000. So we can debug just by checking or taking a look at these event IDs. So these can be shared with support people, and they can then determine why a particular, or rather what was the issue with a particular uh, image that was uploaded, and status can be started, succeeded, failed, or even processing. If processing can be used during debugging, but generally not recommended during production workloads. So let's just go to our application insights. As I said, application insight gives us important features like it gives me server response time that it took 1.91 seconds on an average for my app to process this a particular request. Then it gives me the request that I have received in a particular time period. For example, I have received 10 requests right now because there are different functions that are called for a certain process. Application map gives me a nice graphical view of how my disparate systems are connected to each other. So let's wait for a second. So it shows my function app has connected to the SendGrid API. It is connected to Azure helmet detection application. Then it is connected to the custom vision and computer vision through HTTP call. It is connected to Azure table. It is connected to Azure blob. So we get how the reaction takes place between these components and generally how much time it takes to connect to each one of them. So as you can say, most of the times are really small. Few are in milliseconds, some of them are in seconds, but which makes the system almost react to a certain image capture almost in a real time, I would say, with probably a few milliseconds or seconds of delay here and there. So moving back to our log analytics, so I just want to show you how the structured logging looks and why, if you decide to use serverless, rather use serverless technology to build your products, why you should use structured logging. So I'll just quickly cheat around my way and use the query from history. And what I want to do is, uh, so this one was failed. Let me just copy its name. And hopefully, one thing to remember is that this application insight is asynchronous in nature. So it might take some time after your app has pushed events to the application insights for the events to actually appear there. So let's try this JPG. I'm using the name of the blob. Now let's run the query. So we can see how different things are logged here. Now all of this logging is a structured logging, which is controlled using this particular template. Event description, processing workflow, correlation ID, blob name, and status, stuff like that. And then I have defined my query, which says I want to order them by the timestamp ascending. Then I want to log the level of the log. where it was logged. I want the timestamp, I want the event ID, I want event description. All of these event description, processing workflow, and everything is the structure that we set up inside our Azure Functions project. So if we take a look at it, what it tells me is that this at this particular point of time, at this particular UTC, the helmet detection workflow started, and the processing workflow was detect helmet. So it triggered off. This is the correlation ID. It's the name of the blob. Status is we have. Oh, sorry about that. The blob is was the status is failed. Okay, hold on. Yeah. So let me run the query once again. Okay, so what it says is it says started the helmet detection workflow. It says no helmet was detected. So it successfully published the event to the custom event grid topic. Then another function, number plate extract number plate function was triggered. It says it failed to extract number plate. So now we know where our particular system failed. So this is how our logic, or rather application insights and structured logging helps us in the serverless solution. So that's what I wanted to show you. And probably let's move back to a slide. So this is the last slide for my presentation. So some of the best practices and lessons that I've learned while implementing this project was, as a best practice, we should add at least 50 images per tag to better train the object detection model in custom vision service. So as I've iterated a few times before, more the number of images, better the accuracy. Then we should use a static HTTP client with Azure Functions, because Azure Functions work on a platform which is shared between different Azure Functions project. And now if we use HTTP client and we create instances of that HTTP client, with each new invocation of function will run into socket not available exception, because since it's a shared piece of infrastructure and it still has some limitations on number of active connections that you can have. Probably use singleton instances of API calls, example calls to custom vision, computer vision clients, again in Azure Functions. I can't stress enough the importance of putting up structured and correlated logging in Azure Functions. As I've shown you earlier, it's really important when you are developing loosely coupled and completely serverless systems. It is always a saving grace. And logic app with event grid trigger sometime registers the event subscription again and again when we enable the and disable the logic app. So probably keep eye out on that. And further reading, so I only want to point out to one source, that is MSDN documentation. It's comprehensive enough. So start with it. Probably, and if you run into some issues, you can refer to the advanced topics that are discussed on various blogs, or you can reach out to me in case you run into any uh, issues. So that's all, folks. I'll take questions, and if anyone of you wants to connect with me, have a chat with me after the event, probably these are my details. If you want to reach out on Twitter, my handle is @Mandak003. Want to reach out on LinkedIn, this is my handle on LinkedIn. So that's it from my side. I think I'll stop now, and I'll take questions now. Thanks a lot, and thanks for your patience and listening for me ramble on for almost an hour. Thank you very much. Over to you, Kasam.
Thank you, Mandar. That was really interesting. Guys, anyone do have any questions for Mandar? You can see there are some questions in the chat window. Mandar, can you just have a look in that chat window? Mandar, you there?
Yes, can you hear me?
Yes, Mandar. Actually, there is one question from Altaf that is it possible to have an example of parameterized logic app for CI/CD? I believe Altaf, you need to get in touch with
Well,
Mandar.
yeah,
Yeah, please,
probably
Mandar.
at
Go ahead.
some point. Yeah, sorry about that. As I said, it's not possible at this moment to show the CI/CD for this. I'm still in process of implementing it, but if you want, I can point you to certain blogs that will show you how to do the parameterized CI/CD for the Logic app. So if you want, please get in touch with me later on. I'll point you in the correct direction.
Thank you. Mandar, do you like? Is it possible to have this solution in GitHub somewhere for the attendees to get?
Sure, sure. I'm still cleaning up the code a bit, and once I fix the commenting and stuff like that, I'll make the repository public so that anyone who wants to use it uh, can use it. So let me know how I can reach out to the viewers of this, and I'll probably we can do it via
So
tweet or
what we
something.
So what we will do is, like we are recording this session, so we will be publishing into
Yep.
our Dear Azure channel. So we can give
Mm-hmm.
that later. We can give that GitHub link in the video description itself, so they can reach out directly when the for all the viewers, not only for the attendees, but later on when the viewers view that this recording, they can reach out that
Yep.
to the GitHub and your details. That would be fine, right?
Sure. Sure. Sounds
Okay.
good. I'll make the repository public in a day or two.
Great. So, attendees, thank you for attending today's webinar. I just wanted to update you. There are two upcoming webinars. Like tomorrow, it will be about all about Azure Key Vault service. That is another interesting service for managing your keys and security into your applications. And later next week on 30th June, we have a session for Azure Blockchain. So there we will build an application using a blockchain application with Azure. So please stay connected. Do join tomorrow at the same time, 12:30 p.m. That will be presented by Mohammed Aslam. He is a cloud security expert, and he will be exploring more about how to get started with and how you can manage with Azure Key Vault service. So I will be sharing the link on our Dear Azure LinkedIn page, WhatsApp group, and Facebook page. So do get connected with all these channels for all the updates. Thank you. Thank you again. Thank you, Mandar, for your time. Thank you, everyone, for joining the session. Hope you have
Thanks for
learned
hosting me.
something new.
Thank you, everyone. Have a great weekend. Bye bye.
Bye.